Hey math fans, we're on section 4.3.1. Let's get started. In this section, we're going to be learning how to interpret the slope of a regression model correctly, and also the y-intercept. In example 1, we're showing a linear model. In other words, that line that you see in the graph is a line of best fit, though you can't see the scatter plot, but this is a prediction model that uses the size in square feet to help predict what the cost in dollars will be. So what we're going to do is we're going to calculate the slope and the y-intercept, and then we're going to interpret the slope and the y-intercept. To calculate the slope, the first thing you need to do is identify 2 points on the line of best fit. Make sure that they're going through the actual intersections of the grid. And as you can see in yellow, I've highlighted 2 points, 300, 60,000 and 600, 120,000. Using the slope formula, the rate of change formula, we can get the slope of the regression line. And it simplifies to be 200. The slope of the line of best fit is 200. To find the intercept, you take the slope, which in this case is 200, and you put it into the equation y equals mx plus b. The 200 will go in for m, that's going to be the slope. And then you're going to replace x and y with either one of the points that you chose in the very beginning. And for this example, we're going to use the 300, 60,000. It's always wise to go with the smaller numbers. So we're going to put the 60,000 for y, the 200 is the slope, and then the x is the 300, and that goes right there. And then we just solve for b, and we get that b is equal to 0. So we have a slope of 200 and then a y-intercept of 0. And notice how you don't have, when the y-intercept is 0, you don't have to write the 0. But I'm doing that anyway just to show you that there is an intercept right there. Take a moment to write down this interpretation of the slope. It follows this formula every single time. It's for every increase in 1 unit in whatever your x variable is, your explanatory variable, there's going to be a predicted either increase or decrease. Now, depending on whether or not your slope is positive or negative is going to be the increase or decrease. So if it is a positive slope, it's going to be an increase. We're predicting an increase in whatever the y variable is. So let's actually use the context of this problem. This problem is dealing with the size in square feet as the explanatory variable or the x variable. So for every increase in 1 square foot in size, there is going to be a predicted, now it's, remember, our slope is positive 200. That's our slope. So there's going to be an increase in the cost in dollars by 200 units. So the units are dollars, right? And then the units up here is square foot. So you want to make sure that you write those units. For every increase in 1 square foot, so we wrote the unit there. You don't have to write the word unit. For every increase in 1 square foot in size, there's a predicted increase of cost of about $200. So how do you interpret the y-intercept? Well, it's got its own little formula too. And remember, a y-intercept is when x is equal to 0. So we're going to be putting the context of our x variable, our explanatory variable, in right there. When the explanatory variable is equal to 0, then the predicted, whatever that y variable is, will be so many units. So let's use the actual numbers in this problem. Once again, the X variable is size in square feet. The Y variable is cost in dollars. So when the size in square feet, okay, so when the square footage is equal to 0, these homes have a square footage equal to 0, the predicted cost is going to be $0 because remember, the y-intercept was 0 down here. And that's not always going to be the case. It's not going to always be 0. It could be, the predicted cost could be, $100,000 or something like that. But actually, that kind of makes sense. If you had a 0 square foot home, it probably wouldn't cost you anything. And that's going to do it for this section. We'll see you in class.